In today's lesson, we're going to be talking about Boyle's Law, but before we do that, we want to review a couple things as far as defined quantities go for measurements. So a reminder, a while ago we talked about standard pressure. We said that was 101.3 kPa. Similarly, all those conversions, it would be the same as 760 millimeters of mercury, 1 atmosphere, 14.7 psi, etc. Someone wants standard temperature. They don't need to say 0 degrees C. They say standard temp. They're implying that. And we use the abbreviation STP if we want both standard temperature and standard pressure conditions to be existing simultaneously. So I hope you all watched the little video with the divers demonstrating Boyle's Law on the class page there, where we saw that very clearly as pressure increases, volume decreases. So in scientific terms, Boyle's Law would say that if the amount and temperature of a gas remain constant, the pressure exerted by the gas varies inversely to the volume. So if we're saying that in simple terms, as we saw in the video, that would mean that if pressure goes up, because they're inversely related, volume would go down, and vice versa. Pressure goes down, volume would go up. So if we're going to say that in terms of an equation, so we can solve problems using Boyle's Law, we would be saying that pressure times volume would be constant. In other words, pressure at condition 1 times volume at condition 1 would be equal to the pressure at condition 2 times the volume at condition 2. So as we're solving Boyle's Law problems and future gas problems, we want to be looking for hints in the word problems so that we're not just blindly pulling an equation because we see certain variables present. So our hints for when Boyle's Law would be used would be that is because we need to have the amount and temperature of the gas being constant. So that's what we're going to look for. Do they tell us that the temperature is staying the same or that the amount of gas is staying the same? And that could be implied. It might just simply say that without saying any more gas was added or taken away, we know that the amount is being held constant. So let's solve some Boyle's Law example problems. So as we read the problem, we want to first look for hints that we know that indeed we want to apply Boyle's Law. And we see here that they're telling us both the temperature and the amount of gas are constant. So we know that we can use P1V1 equals P2V2. So now it doesn't matter which set of conditions we call condition number 1, we just need to make sure that we put the right set of conditions together. So we have P1V1 equals P2V2. So let's call the first one they gave us condition 1, and we will call the second one condition 2, and they're asking us to find the volume. So now we simply need to plug in our different variables with their units. So pressure 1 is 86.1 kPa. And volume 1 is 338 centimeters cubed. And we're going to set that equal to condition 2, and that is 104.0 kPa, and we are solving for V2. So notice both pressures are kPa, so we can continue. If they were in different units, we just have to make sure they were both the same. So if the second one had been in millimeters of mercury, we'd change that to kPa, and then we could continue, right? So now it's simply doing some basic algebra here. We'd have the 86.1 times the 338. Our kPa's would have canceled. And divide that by 104. and we would be left with V2. It would end up being in centimeters cubed because that is the unit of volume on the other side. 3 significant digits when we look at all our different variables used, and we put that in the calculator, and I get 280. We need to put the decimal there so that we have our 3 sig digs. Our second example, right? Let's call this that would be volume 1. We'll call this pressure 1. And they are giving us not a number, they're saying standard pressure. We can use any standard pressure unit that we want, but because the unit on pressure 1 is kPa, we're going to say we want to use the standard pressure of 101.3 kPa for condition 2. And again, we are looking for our volume. So again, we know we're using Boyle's law because temperature and amount of gas are constant. So P1 V1 is going to equal P2 V2. And now we just plug in all our variables and check that units are good. So we have 105.9 kPa times 77.0 meters cubed. And on the other side, we are going to have 101.3 kPa. I know 1 atmosphere is also standard pressure, but because this was in kPas over there, we want it in kPas over here. And we are solving for V2. Okay, so units on opposite sides are going to cancel. We can see that volume 2, we know the units will be in meters cubed because of this. And now we just do our different numbers here, and we get this as we rearrange our numbers, basic algebra, plugging that in our calculator, and let's check. We would again want 3 significant digits in our final answer when we look at the original data, and I get 80.5, that would be meters cubed for volume 2. So for homework here, please look on your class page and you'll see the assignment posted from your text for the day. Thanks.